All right, so we have got we've gotten to our last page, and like I said, this is going to be a culmination of everything. It's going to be kind of like that. Oh, okay, I kind of get now why we do these trig identities, because today, page 11, page 12 is solving now for these trig functions. Okay, we're actually going to be solving for x. It's going to be very methodical, meaning I'm going to be as organized as I get with a step 1, step 2, step 3, blah, 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 as we go on. And as I write down the steps, I'm going to write the steps at the top. Then as we work them, you'll see them. I'll make it match up exactly with the work that we're doing as well. One thing I want you to pay close attention to is the directions. It says find all solutions to the equation in this interval. This should be a bright spot. Even though it's beautifully sunny outside today, it's going to just get sunnier. If we're finding all the solutions, and it's written as like cosine x, sine x, and we understand that sine, cosine, and tangent, everything right after that is an angle measurement. So it's sine theta, cosine x, sine u. Those values, x, u, theta, all represent an angle measurement. So what we're finding today on page 11 and on page 12 is an angle measurement. Each one of those angle measurements is in radian measure. What hour is this? 4th? Lunch.
Get out of here.
Lunch. 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 I'm going. Sorry for anybody that's listening to this. We had a little minor. So I'm not the only one that thinks you're sassy?
Well, I can call it Sassy McGee and Sassy McGee.
Yeah. Okay, so here we go. So we're looking for an angle measurement, but when it's written in terms of being specific in this interval 0 to 2 pi, we can not have, we don't have to worry about those restrictions that we had talked about before, where I only can pull angle measurements for sine in the first and the fourth quadrant. I only can pull angle measurements for cosine in the first and the second quadrants. This is saying the whole unit circle is our ball field. We can play on any of those quadrants. So when I'm looking for sine, I can choose first, second, third, fourth quadrant if I want to. I don't have to be restricted to any particular quadrant because it's saying I can look for angle measurements in this interval from 0 to 2 pi. Pay close attention. I've got brackets, which means 0 is included, as is 2 pi. So for instance, if I have anything on my unit circle that, for instance, if cosine is 1, I would write down 0 radians and 2 pi as well. So both of those would be included for anything, any value at this spot right here, because 0 is included, as is 2 pi. And as we move forward, hopefully that's going to make a little bit more sense, okay? That is very important to know that. The second thing to know before we get started is do not divide any. I have this up on the board, but I'm going to put it in the notes so that it's on the video as well. And I'm just stepping aside from our notes for a second. That if I would have just x times y squared equal to x, let's just say that that's an equation and I say to solve it. Okay, if I say to solve it, what would be a logical first step? Divide by x. And then I get y squared equals 1. Okay, absolutely. Great first step. But what they're saying when it says do not divide any, and I'm going to go to number 53 because that's the problem we're going to be working, I'm not going to be dividing by tangent, because by dividing by tangent, I'm getting rid of tangent, and I need tangent to be part of my solution, okay? And as we work through these again, I think that's going to make a little bit more sense. But so as we go through these, dividing of a trig function is not acceptable. Dividing by a trig function is not acceptable. Dividing by numbers, 1 divided by 2 to get 1/2, absolutely. But dividing by trig functions, we're not going to be doing, okay? All right, we ready? Okay, just make sure that you can see what I'm writing here. I'll do that so that it can show up a little bit better. All right, step 1. Because we are not dividing, we are going to set our equation equal to 0 as our first step. So number 1, set equal to 0. Okay, set equal to 0. So then I'm going to go down to number 53. And step 1, if I want to set tangent x sine squared x equals to tangent x, how do I get that set equal to 0?
Tangent x sine squared x minus
I'm going to subtract tangent from both sides. Exactly. And I've got it set equal to 0. Okay, step 1, check. Set equal to 0. Step 2. Then I factor. And on this page, the front page here, page 11, the factoring is going to be more just finding a common factor that I'm going to be pulling out. The next page is going to be the factoring like we saw yesterday with a trinomial, okay? So here I see tangent x times sine squared x minus tangent x. What can I factor out?
tangent x.
I'm going to factor out a tangent x because that is a common factor. And I'm left with sine squared x minus, what's tangent divided by tangent? 1. So I'm left with tangent times sine squared x minus 1. Okay, so I factor. Once you're in factored form, meaning I've got a factor times a factor, I've got two things that are being multiplied together, then I use the zero product property. Say what? Stay with me. Use zero product property. So step 3, zero product property says that if I'm in factored form, I'm going to take each factor and set each factor equal to 0. I'm going to set each factor equal to 0. But it must be in factored form. Okay, so that it has to be being multiplied together to set it equal to 0. And then step 4, I'm going to use my unit circle to solve. Okay, use your unit circle to solve. So I go up here to step 4. So what I have is I've got tangent x equals 0. This x represents my what? My angle measurement. And remember, I want that angle measurement in radians. So it means I'm looking for an angle. So I'm looking for the inverse of tangent, where tangent is 0. And that's going to give me my angle. So I go to my unit circle. And this particular unit circle that I have has my tangents written on the inner part of the circle. The ones that we've done together, I think we might have stuck them underneath our sine and cosines over here, okay? So I look at my unit circle and I find any place where tangent is 0. Well, at the get-go, it's 0. So I know that I have 0 pi and 2 pi is included. I keep going around. Oh, there it is again. What else is included? Pi. And then I'm back to my 2 pi. So here, x is equal to 0 pi, pi, and 2 pi. Bless you. Then the second one, I need to get it into proper form because sine squared minus 1 doesn't help me any. So I need to get to just sine. So now I have sine squared. I added 1. Sine squared equals 1. Get rid of the sine squared. So I take the square root. So sine's going to be plus or minus 1. Square root results in a plus or minus. And the way I look at that as the inverse sine of a positive or negative 1 is going to give me my angle measurement. So I go to my handy dandy unit circle. Sine is my y value. Where is sine 1? Ding, 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 pi over 2. Where is sine negative 1? Ding, ding, ding. Can you see that? 3 pi over 2. So here, x is pi over 2 and 3 pi over 2.
If you converted sine squared x minus 1 to negative cosine squared, would you get the same thing?
Yeah. But the question is, why would you do that?
You see it?
But you could.
Okay.
Absolutely, you could. And you would get the same answer. Right up here. So now I've got step 5, which really don't need to write it as step 5, but you want to write as solution set. Since it gave me an interval in which I'm going to find my solutions, I'm going to write my solutions in that interval. So I start with 0 pi, and hopefully you write them in order. Pi over 2, pi, 3 pi over 2, and 2 pi. And then that's my final answer all the way through. Okay? Questions? And Eddie, back to what you're saying, because it's written as sine squared x minus 1, absolutely, you could have, because then you would have had to add 1. Now that I'm looking at it, that makes a lot of sense, being able to do that, convert it, but it's not necessary, because you could add 1 and then just take the square root, whereas cosine, if you, I mean, it's one step here by adding 1 or one step converting it to cosine, but you will get the exact same answer. Yep, good point. Okay, flip to page 12. That was Stephanie. Okay, page 12. Back page. Here. Yeah, right. Back here it says we want to find all solutions to the equation, but I'm actually going to change the directions a little bit. We're going to find the solutions exactly like what we have been, okay? Same using the interval of 0 to 2 pi. If we're finding all solutions, I just want to explain this, even though we're not gonna solve them in that way. If we're finding all solutions, you would actually be adding a 2 pi times n to every angle measurement that you find. N standing for the number of rotations that angle makes. So if you're looking at an angle that makes, like, 3 rotations, you would have 3 in here, and that is not 3 rotations. That was actually a good-looking snail, if you wanted my opinion on that. But with a necklace or something, I'm not sure what that is. But that represents how many numbers it goes around, and then times 2 pi. We're not going to do that. We're going to stick with exactly what we did. The only thing different on this page is the way in which we factor, okay? Everything else is going to be the same. So step 1, set it equal to 0. Check. Step 2, factor. So 4 cosine squared minus 4 cosine plus 1. What I have here, and what I want you to recognize, is I have a perfect square trinomial, meaning my 4 is a perfect square, 1 is a perfect square. So I'm able to automatically set up my binomials recognizing that this is a perfect square trinomial. So what times what gives me 4? So 2 cosine x goes in the first spot on each one of those binomials. What times what gives me 1? 1 and 1. That is a positive 1, but the middle term is negative, which means they both have to have the same sign. That's what the positive represents. It has to be either plus plus or minus minus. And since the middle term is minus, they both have to be minus. Okay? That is a perfect square trinomial. Now, because both of my binomials now are identical, I only need to solve for 1. So I'm using the zero product property, setting it equal to 0. And again, the only reason why I'm using 1 is those are identical, and I'd just be repetitive. So 2 cosine x equals 1, cosine x equals 1/2. So that's just asking for the angle measurement when cosine is 1/2. So you go to your handy dandy unit circle. And again, what's nice about this is I don't need to worry about what quadrant I'm in. I can find it anywhere. Cosine is my x value. So cosine is 1/2 at pi over 3. And I go around and I'm looking for a positive 1/2. And there I am again at 5 pi over 3. So x equals pi over 3 and 5 pi over 3. Writing it as a solution set, I get pi over 3 and 5 pi over 3, and that's my answer. Okay? Now I want to jump down to number 60 because we have a little extra step that we have to do in 60 before we can actually get into the solving part. And I want to bring that to your attention first. So number 60. We have 3 sine x equals 2 cosine squared x. All right? I am not set equal to 0, so that's a good first step. So I'm going to subtract 2 cosine squared x from both sides. I get it equal to 0. Now I recognize that I have a problem. I want a factor, but I've got 2 terms. And there's not a common term between sine and cosine, because that's what we had on the previous page when I had tangent and sine. Tangent was able to be tangent was a common factor. I was able to factor the tangent out of both of those terms. But here there's nothing that I can factor out. So what I am faced with is a minor little problem. And this is where we come into what we did yesterday. We take the cosine squared, knowing that I can rewrite that in terms of sine. So what is cosine squared? 1 minus sine squared. That's our Pythagorean identity, is 1 minus sine squared. So I'm going to rewrite this. This is exactly what we did yesterday. I have 3 sine x, that's going to stay put, minus 2, that's going to stay put. But the cosine squared that's being multiplied by that 2 is going to get substituted in for the 1 minus sine squared x. So I get 3 sine x minus 2 times 1 minus sine squared x, because that 1 minus sine squared x is identical, it's a replacement for cosine squared x. And that it comes straight from our Pythagorean identity. Sine squared x plus cosine squared x equals 1. And rewriting it, I would get that. Now the next step, I'm just going to distribute that negative 2. Negative 2 times 1 is negative 2, and negative 2 times negative sine x is a positive 2 sine squared x equals 0. Now I want this in standard form, so the sine squared is going to come out in front. So I get 2 sine squared x plus 3 sine x minus 2 equal to 0. And at this point, I am actually going to show the next piece using, because we need to factor it. It's set equal to 0. I'm all in terms of sine. It's a trinomial, not a perfect square trinomial. Nothing about this is like a shortcut to the factoring. So therefore, I'm going to actually step you through the AC method on this, okay? So I set up my x, and I look at 2 times negative 2 is negative 4. So 2 numbers that multiply to give me negative 4. My middle term is 3. I need 2 numbers that add to be 3. So what 2 numbers multiply to give me negative 4, but add to be positive 3? 4 and negative 1. So those two values right there replace my middle term when I go to rewrite it. So I'm going to have, now, what I'm going to do, and I don't know if this is helpful, I hope it is, but I'm going to rid myself of the sign. And I'm just going to write 2x squared plus 3x minus 2. And then at the very end, I'll bring in the sign, okay, if that gets too confusing. So this is the same thing as saying 2x squared plus 3x minus 2. Okay, so I'm going to replace the 3x with the 4 and the negative 1, and it's going to be written like this. 2x squared plus 4x minus 1x minus 2. Because that middle term right there is the same thing as 3x. I took the one term and divided it into two terms. Now I'm going to use grouping by putting parentheses around the first two terms and the last two terms. Pulling out a common factor, I can pull out a 2x and I'm left with x plus 2. The second binomial, I'm going to pull out a negative 1 and I'm left with the same binomial, I better, of x plus 2. So I get x plus 2 times the coefficients of 2x minus 1, making up that second binomial, equals 0. Now I've got my factors. And then I'm going to substitute in my sign anywhere that there's an x. So I'm going to have sine x plus 2 times 2 sine x minus 1. And now I can pick up right where I was. That was all step 2 of factoring. Now I'm going to set up the zero product property. So sine x plus 2 equals 0, and 2 sine x minus 1 equals 0. And I'll solve. Sine x equals negative 2. 2 sine x equals 1. Sine x equals 1/2. Using my unit circle, I will try to find where is sine x equal to negative 2. Anybody find a negative 2 on your unit circle? You won't. Therefore, that is no solution. You cannot find anything where sine is going to be negative 2. So the only solution comes where sine x is 1/2. So I look and find the angle measurement when sine is 1/2. Pulling out my unit circle, I see pi over 6 and 5 pi over 6. And I write that in set notation.